Hello guys, welcome on Tesla Adventures. After a heavy demand to start fluids, I was receiving messages on YouTube as well as on my personal mobile number that sir please bring fluids. So after such a heavy demand, I am here with fluid mechanics and I am ensuring you like our content, other content in our channel, this will be the most complete and most high level, Olympiad level fluid playlist which is made ever in YouTube or the content which I will be giving in this playlist would be the most proper content which would not be received in your physical coachings or in any paid course or in any YouTube playlist. I guarantee you this thing that this would be the best playlist of fluids. So let us start with the first topic, that what is fluid. So if we generalize the materials which can flow, so we came up with the common name which is called as fluid. So fluid is actually the name which is used to refer the materials which can flow, like gases and liquids. Okay, and we can technically define the fluids as the materials which cannot resist the tangential force. Hence, when some tangential force is applied on the fluid, then it begins to flow. So we know that if we apply some tangential force on water surface or on gas, then they will start to flow. But the solid, when we apply a tangential force on solid, then solid will resist that tangential force and it will not flow. So this is the technical definition of fluid. Now, what is fluid? So fluid, ideal, what is ideal fluid? Now, ideal fluid, which obviously do not exist, but ideal fluid is a imagination of such a fluid which is incompressible, which means that its density does not changes at any point, and it is non-viscous, which means that the viscosity, which is the internal layer friction between the layers of the fluid, is not present in that ideal fluid. So that is the ideal fluid, and we will be dealing with the ideal fluids in this section. Now, if we subdivide the fluid mechanics, then we can say that it is divided into three parts, which is fluid statics and fluid dynamics and viscous fluids. So in fluid statics, we would be dealing with those fluids which are obviously ideal and are at rest. In fluid dynamics, we would be dealing with the flowing fluids which are flowing. And in the third section, in which it is written that we will be dealing with viscous fluids, in that section we would be discussing about viscosity, surface tensions, and those quantities which are seen in non-ideal fluids. Now, what is density? So you all know the density is the mass of any material per unit its volume. So that is density. And what is relative density? So relative density is actually the ratio of density of a given liquid to the density of pure water at 4 degrees Celsius. This ratio is called as relative density, and we know that the density of pure water at 4 degrees Celsius is 1 gram per cc. 1 gram per cc at 4 degrees Celsius. And what is specific gravity? Now, specific gravity is also such ratio in which it is the ratio of weight of the liquid to the weight of pure water at 4 degrees Celsius. So if we use this formula, then G will be cancelled out, and obviously this will be rho L by rho W. And numerically you can see that specific gravity and relative density are equal. Relative density and obviously specific gravity are numerically equal. So this is the important thing to note. And dimensionally, both quantities are dimensionless. There is no dimensions of specific gravity, neither there are dimensions of relative density. Now, now when the different types of liquids are mixed, which are in proportion of mass, which means that if m1, m2, m3 are different masses of the liquids, and rho 1, rho 2, rho 3, rho n are their densities, and they are mixed, then the density of the mixture obviously can be written as the total mass, which is m total divided by v total, total volume. Okay, so the total mass will be m1 plus m2 up to mn, and the total volume of the material will be, volume is mass upon density, so it would be m1 by rho 1 plus m2 by rho 2 up to mn by rho n. So this is the density of the mixture in this case. Now when the liquids are mixed in the proportion of volume, then the density of the mixture will be equal to m total. Now m total mass will be volume into density. So V1 rho 1 plus V2 rho 2 up to Vn rho n divided by total volume, which is V1 plus V2 up to Vn. This will be the total mixture density. So guys, in this video we are just closing up, because this was just a introductory video of fluid mechanics, and from the next video we'll be bringing up the variation of pressure with depth in a liquid. Thank you.